Another situation you will encounter in probability will be at the time when you have dependent event. Simply, you can say the occurrence of the second event is affected by the first one. Normally, it occurs in the situation like example 29, where we have uh, getting two letters or two items with the replacement. Or maybe, for example, you are getting two balls from a bag at the same time. So let's see the situation one by one. So now you are having the word called dependent and you are getting two letters with the replacement. That means, for example, you get the D, you can't get this D at the next time. If you get, let's say, if you get the word N, so you have one less N in the second chance. So now when you want to know what is the probability of both letters to be vowels, that means you are talking about A, E, I, O, U. So the required probability will be as follows. Now you count the numbers of letters 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 possibilities are there. If you want to get vowels, that means, okay, let's see. Vowels you have E, 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 totally 3, right? Okay, this is the first letter you're going to pick. Well, after you get one of them, there are 3 E's you're going to pick up. Okay, so that's why there are only 8 letters left behind, and there are 2 E left behind accordingly. So this is the situation of dependent event. And you will see that the significance will be, normally the denominator will be changed because you get one item or like one letter in this example already. And the top number may be changed accordingly. So but by the way, because you are doing two actions, that means you're getting two letters, so we multiply the things together, which gives you 1/12. Next, let's take a look in example 32. There are 3 pairs of white socks, 2 pairs of black socks in a drawer. In common, going to take out 2 socks. Now be careful, it's pair and socks. So that's why totally, how many socks are there? 6 are white, 4 are black, it's totally 10. So I like to mark the total number next to question to help myself. And you're randomly taking 2 socks from the drawer, and you can see the keywords without replacement, reminding you it's about dependent events. And for part A, so now let's start doing the question together. Part A, so your required probability. Okay, you want to get both of them are white, so that's why at first there are 10 socks, where 6 of them are white, and followed by, so there are only 9 socks left behind, in which 5 of them are white. So this is the second event, which affected by the first event accordingly. And finally, you get 1/3. Not very difficult, right? And next, another situation would be you want to get same color. Same color, that means is white white or black black. So there are 2 situations, right? So that's why the required probability consists of 2 parts with adding up together. Well, for the first one, it's fine already. So the results of white white. Now you're going to find the black black. Black black, so first of all, it's 4 black socks out of 10, whereas the second chance will be there are 9 left with 3 of them are black. So by calculator, you get 7/15. So there's another situation of dependent events. And last example 33 is a more complicated one because it's talking about percentage. And personally, I like to use decimal number to talking about it. Okay, now let's take a look at the question. You have male 52%, 50% of female are smokers, 80% of male are non-smokers. Now can you see that there are 2 categories? One is about the gender, male, female. The other category will be smoker, non-smokers. So in this situation, bear in mind that drawing a table, not really a table, a tree diagram or diagram may help you. So I like to do it in this way. So first of all is male 0.52 male. So that means the opposite complementary event, female is 0.48. Okay, smoke, not smoke, I use tick and cross. Smoker, you have, Okay, male non-smoker is 0.8, that means smoking is 0.2. Female smoker is 0.15, that means the opposite, 0.85 for non-smoking. So that's why it clearly indicates every information in a simple diagram, tree diagram. So repeat, bear in mind that when you have two categories to consider in probability, do try to draw a tree diagram to visualize the question. Now let's see. Okay, part A, required probability. So a female smoker is chosen. Okay, female smoker is chosen. So that's why you first choose a female, then choose a smoker. And as a result, is equal to 0.48 times 0.15, 0.072. Is that okay for you? Choose a female first, then smoker. A male smoker is chosen. Male smoker, male, okay, male smoker. So in part B, I leave it to you. The hardest job will be in part C. You are talking about a smoker is chosen. So how can we do it? If you read the question carefully, part A is female smoker, part B is male smoker. So add up together. Okay, if you add up together, then it gives you the answer for part C. A smoker is chosen. That means you have the answer in A, female smoker. Answer in B, properly you have got it 0.104, and total is 0.10, not 10, 176. So this is a situation of the question. After you have a better understanding of dependent event, then we come to the last and the most difficult part called conditional probability. So it's talking about two events, one occurred after the other. Normally we have F, the second one, E, so we call F after E has occurred, with the symbol called PE given E, PF given E. And then so the formula will be given by, okay, so let's wait. So it's called PF given E will be equal to probability of PE and F divided by PE. E, remember, is the first event. Okay, you can simply like E is the first event, it first occurred, while F is the second event, that's the event followed. So what was the question will be setting? And then so I will use the situation example 33 once again. Okay, so let's start as follow. Okay, 34, so it's still talking about smoking and non-smoking, and then I draw the tree diagram once again for our convenience. Okay, male 0.52, smoke, not smoke, 0.2 and 0.8 respectively. Okay, female 0.48, smoking, non-smoking 0.15 and 0.85. So let's see how the question will be asked in conditional probability. Okay, so the keywords of conditional probability is always starting or given by given that. That means something occurred already. For example, like part A, given that a female is chosen, that means we start from this point. We need not to consider 0.48 already because female is chosen. So that's why if she is a non-smoker, and you just read the answer, it's 0.85, that's all. But it's very different to example 33A, which you need to choose a female as well as non-smoker as well. And then so the hardest job would be talking about part B and part C. So let's read them one by one. Now, given that a smoker is chosen and you want to find the probability that he is a male, then there's a trouble because in this tree diagram we can't start from smoking first. So in this situation we need to use conditional probability to like kind of swap the situation. So that's why I will write the events very clearly so that I can apply the formula accuracy. E will be the first event called smoker chosen. Okay, a smoker is chosen, while F will be he is a male. So that's why PF given E. So it's given by, so you spell the formula, it's PE and F divided by PE. So what does that mean? E and F. Okay, E and F, that means it's a male smoker. So it's 0.52 times 0.2. So what's the meaning of PE? PE, you're just talking about a smoker chosen. So that's why you have male smoker, female smoker. So which is 0.52 times 0.2 as well as 0.48 times 0.15. So it's pretty long because you're talking about smokers. And then now you check the calculator, it's 13 over 22. So see whether you can get the answer or understand the question quite well. The key will be if you identify that the question is about conditional probability, and so you list out the events, first one and second one very clearly, apply the formula, and find the probability respectively to get the result. Okay, so let's try to take a look in part C to see whether you get the result properly. So given that a smoker is chosen and you are asked to find the probability that she is a female, and I have no space, how about put it on top in yellow. So this time E is smoker chosen, F, so you want to have a female. So that's why PF given E will be PE and F divided by PE. So let's start. PE and F, that means smoker female smoker, that means so it's 0.48 times 0.15. Bottom one, right in green, PE, that's smoker chosen. So it includes male smoker, female smoker. So that's exactly the same denominator in the previous one, right? So last, you also use calculator, is 9 over 22. That is, if you're smart enough, you will see that, well, the question is smoker chosen, male, female. So can you see that it's complementary events? So that's why part C, you can simply use 1 minus the answer of part B to get the answer very quickly. So this is a very good use of complementary event in the question. So you find conditional probability is very hard, right? So that's why you need more practices, or you need to see more examples to get familiar with it. So let's go back to the textbook to find more examples. So while in now example 35 and 36 give you another view of conditional probability that we sometimes need to consider the formula itself. And let's see whether you have a better understanding in this way. Somehow I would say it may normally happens when you're talking about two events, or sometimes throwing two dice because a table may help. So let's see. Part A, find the conditional probability that both dice show odd number. So odd numbers, so that means it may be like 1 1, 1 3, 3 5, etc. So it's very dangerous to count it in this way because it's very easy to miss certain numbers, certain pair. So that's why I suggest you, when you're talking about throwing two dice, drawing a table is very, very useful in listing out the results and consider the question. That's my part A, and now you can take a look. When you have both odd numbers, you have 1 1, 1 3, 1 5, 3 1, 3 3, 3 5, 5 1, 5 3, 5 5, right? So totally 9 results. Okay, that is 9 over totally 6 times 6, so which gives you 1 over 4. That's all. Easy, right? Okay, now we come to the situation. Find the probability that both dice show odd number, given that the sum of the numbers is greater than 7. Wow, it's very terrible, right? So if you read the question, that given that means it's conditional probability. And then now, what's that? Given that the sum of the numbers is greater than 7 is event E. Both dice show odd numbers is event F. Of course, you can use the formula previously to get the results. But now in these two examples, I would like to show you that conditional probability, in the case when you use a table, you can use a table, then you can understand in this way. Given that, that means we now no longer consider a question as 6 times 6 because we don't have totally 66 results. What do we mean by conditional probability? So in this, it's talk about some greater than 7. That means you have greater than 7, you have 2, 6, right? Okay, I highlighted in this way. 2, 6, 3, 5, okay, 3, 6. So I read out the numbers one by one. I just highlight them carefully. So these are the results of sum of the numbers greater than 7. Can you help me to count the numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 in total. So that's the real meaning of conditional probability. You are narrowing down the consideration of the total possible outcomes. Now you have only 15. Okay, according to it, how many of them are both numbers show odd? You have the original 3 over there in this region. So that's why you have 3 and give you 1 over 5. Is it much easier than before when you consider conditional probability? Hopefully yes. So the situation where we can apply such method, repeat, is only when you can list out all the outcomes, like in a table in this question. Then you can do the conditional probability kind of like in drawing. But this method is not applicable in the previous example because you can't list out the situation of male, female, smokers, non-smokers in a table quite easily. If you think it's pretty good for you to get such an idea, let's try example 36 by yourselves.